Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're wrapping up our chapter on threads with a look at some real-world operating system examples. Sheila, shall we dive right in?
Absolutely, Victor. Before we get into the specifics, let's quickly recap what threads are for our listeners. Threads are like lightweight processes that share the same memory space within a process, allowing for efficient parallel execution. Now, let's see how two major operating systems implement them: Windows and Linux.
Great reminder, Sheila. Let's start with Windows. In the Windows operating system, threads are implemented as kernel objects. This means that the Windows kernel is directly involved in creating and managing threads. Windows uses what's called the one-to-one threading model, where each user thread corresponds to a kernel thread. Sheila, what are some implications of this approach?
Well, Victor, the one-to-one model in Windows provides several advantages. First, it allows for true parallel execution on multi-core systems, as the kernel can schedule each thread independently. It also means that if one thread gets stuck waiting for input or output, other threads from the same process can still run. However, it does come with some overhead, as creating and managing kernel threads requires more resources than user-level threads.
Excellent points, Sheila. Windows also provides a rich set of thread-related functions through its Win32 API. These include tools for creating threads, synchronizing them, and managing their priorities. Now, let's shift gears and look at how Linux handles threading. What can you tell us about that?
Linux takes a slightly different approach, Victor. In Linux, threads are implemented using the clone system call, which is more versatile than just creating threads. It can create processes as well, depending on the instructions given to it. Linux uses what's called the native POSIX thread library, or NPTL for short, to implement POSIX threads, also known as pthreads.
That's fascinating, Sheila. So, in essence, Linux doesn't really distinguish between processes and threads at the kernel level, right? They're both just tasks to the kernel. This approach is sometimes called the everything is a process model. How does this compare to the Windows approach?
You're absolutely right, Victor. This is a key difference between Windows and Linux. In Linux, threads are essentially lightweight processes that share certain resources. This model provides flexibility, but can sometimes make thread management a bit more complex. Linux also supports the one-to-one threading model, but its implementation is different from Windows.
Excellent comparison, Sheila. Now let's talk about thread libraries. Both Windows and Linux provide thread libraries that simplify some of the complex details. In Windows, we have the Win32 thread functions, while Linux uses the POSIX threads library. These libraries make it easier for developers to work with threads without worrying too much about the underlying system.
Absolutely, Victor. And it's worth noting that these libraries often provide similar functionalities like thread creation, joining, and synchronization tools. This means that while the underlying implementations differ, the high-level concepts of working with threads remain similar across different operating systems.
Great point, Sheila. As we wrap up this episode and our chapter on threads, what would you say are the key takeaways for our listeners, especially those preparing for interviews?
I'd say the most important things to remember are: first, understand the difference between kernel-level and user-level threads. Second, be familiar with the one-to-one threading model used by both Windows and Linux, but remember that their implementations differ. Third, know that Linux treats threads more like lightweight processes, while Windows has a more distinct thread concept. Finally, be aware of the existence of thread libraries like Win32 and pthreads, which provide tools for working with threads.
Excellent summary, Sheila. And that brings us to the end of our episode and our chapter on threads. Thank you, listeners, for joining us on this journey through the world of operating systems. Stay tuned for our next episode where we'll be diving into a new exciting topic.